Hi, in this session we will look into some of the examples for KVL and KCL. In last session we went through the statement of KVL, KCL and also with an examples. Let us recall KVL and KCL here. Kirchhoff's current law states that algebraic sum of currents meeting at a junction or node is equal to 0, or we can also say sum of currents entering a node or junction is equal to sum of current leaving the node or junction. And KVL can be stated as algebraic sum of voltages in a closed loop is equal to 0, or algebraic sum of voltage drop of all the branches and the EMFs in a closed loop is equals to 0. So with that basic statements, and also we just saw how the sign convention can be considered when we apply the KVL. That is, when we go through a closed loop, if we find the sign changes from minus to plus, then we have to consider such voltage as positive, and if the sign changes are from plus to minus, then we have to consider such voltages as negative, because there will be a drop in potential for negative voltages and for raise in potential for positive voltages. Okay, so now let us see the first example, and we'll see how KVL KCL can be applied to find the different unknown parameters like currents and then voltages. Here the problem statement is apply Kirchhoff's law and find the current I1, I2 and voltage drop across all the resistances. That is, voltage drop across R1, R2 and R3 we have to calculate, and also the currents I1 and I2 we need to find. So since there are two loops, there are two currents, so I1 and I2. So we can take the loop direction either in clockwise or anti-clockwise as per our convenience. Now I have taken in the anti-clockwise direction for the first loop and clockwise direction for the second loop. So now we will see how the KVL can be applied for the first loop. So that is taking the loop 1, D, C, A and B. I repeat, D, C, A and B. Okay, for the loop 1, here the voltage drop across R3, let us call it as VR3. Voltage drop across R1, let us call it as VR1. For R2, it is VR2. Okay. Now, so going from D to C point for the first loop, voltage drop across R3, you can see the sign changes from positive to negative. Here there is drop in potential. Therefore, this VR3 can be taken as negative. So it is minus VR3. Minus VR3. Now consider R1. Now moving from point C to A, we can just see the potential changes from plus to minus. Therefore, again there is a drop in potential across the resistor R1. Therefore, VR1 can be taken as negative here. It is minus VR1. And for V1 voltage, so you can see the sign changes from minus to plus. Therefore, it is plus V1 or plus 84, which is nothing but plus 84 equals to 0. Now for the second loop, so let us go from the point E, F, D, C, E in a clockwise direction, or you can also start from D, C, E, F, D. So we'll start from the point E, F. So here you can see the sign changes from negative to positive. Therefore, V2 is positive. Let me just highlight. For V2, sign changes from negative to positive. Hence, V2 is positive. That is plus 21. Now, we will just continue the loop from the point D to C. So here, observing the voltage drop across R3, when we take loop 2, it is plus and minus. Therefore, VR3 is negative. So, minus VR3. Similarly, for the branch C to E, the voltage drop across R2, we can see the sign is from positive to negative. Therefore, there is drop in potential. Hence, VR2 is negative for the loop 2 minus VR2. So, it is plus 21 minus VR3 and minus VR2 equals to 0. Now, let us substitute the different voltage drops. Here, let us assume the current meets at point C as I1, and for the second loop, we will take the current as I2, which meets at point C. And so, at this particular branch, that is through R3, the current flowing, let us call it as I3, which is according to KCL, sum of current entering to this junction C, that is I1 and plus I2 is equal to I3. Therefore, so here through the resistor R1, current I1 flows, through resistor R2, current I2 flows, and through R3, I1 plus I2 current will be flowing. Hence, we can write VR1 as I1 into R1, VR2 as I2 into R2, and VR3 as I1 plus I2 into R3. So, R1 is 12 ohms, R2 is 3 ohms, and R3 is 6 ohms. By substituting, we will get the value for VR1, VR2, and then VR3. Now, these value, let us put in these two loop equations. Okay, therefore, the first loop equation, that is 84 minus VR1 minus VR3 equals to 0 becomes 84. VR1 is 12 into I1 and VR3 is 6 into I1 plus I2. Next, consider the second loop equation. We will substitute VR3 and VR2. Therefore, the second loop equation becomes 21 minus 3I2 minus 6 times I1 plus I2 equals to 0. Now, we have to calculate I1 and I2. Let us simplify these two loop equations. That is, on simplifying, you will get the loop equations like this way. And for further simplification, let us reduce the magnitude of these two equations. Hence, we are dividing by 6 for the first equation, and for the second equation, let us divide by minus 3. And hence, the two equation becomes 3I1 plus I2 is equal to 14, 2I1 plus 3I2 is equal to 7. Now, we have obtained two simultaneous equations and we have to calculate two unknown parameters. Here, number of simultaneous equation and number of unknown parameters are equal. Therefore, we can find them by solving these two simultaneous equations. We have to eliminate any one parameter here, that is either I1 or I2. So, to do such simplification, we have to match the magnitude of any one, any one parameters, that is either I1 and I2, and then we can do the subtraction in order to eliminate one parameter. So, the simple way is, let us take the first equation and multiply it with 3. So multiply this equation with 3. So it becomes 9I1 plus 3I2 is equal to 14 into 3. That is 42. So here it becomes in this way. Now let us subtract. On subtracting, I2 will be eliminated, and so we get I1. 9 minus 2 is 7. 42 minus 7 is 35. So we will get 35 by 7, which is 5 for I1. And on substituting the value of I1 in any one of these two equations, we will get I2 as minus 1 amps. Here, no need to bother about the negative sign for I2. It indicates that whatever the direction we have assumed for I2 is in opposite direction. That is, we have assumed the current flows from point E to C, but actually it flows from point C to E. Okay, no need to bother about the negative value. Only thing is our assumption is in opposite direction. Okay, so which we have indicated here. Now we know the value of I1 and I2. We can easily find the voltage drop across each resistor. VR1 is I1 R1. Let us substitute the values of I1, I2 and then I3, and we can obtain the value of voltages for across 3 resistors. Okay, so this is how we can apply the KVL and we can solve the DC circuit. Let me take one more example. So another simple example. For the given circuit, find the current through 2 ohm resistor. Here again we have 2 loops in this circuit. Through loop 1, current is assumed as I1, and through loop 2 we have assumed current as I1 minus I2, and through the 2 ohm resistor the current flowing as I2. Otherwise we can also take through loop 2 as I2 current, and the resultant of I1 and I2 can be taken through the 2 ohm resistors. Okay, in this case I have assumed the 2 loop directions in clockwise. So let us apply KVL for the first loop. Before that, let me just represent the sign for considering the voltage drops. Here it is plus minus. Since we are finding the plus over here, let us take for this resistor the voltage drop as plus minus, and here plus minus, and here plus and minus. So in some cases the direction of the currents will not be given, so we have to assume it. So to apply the KVL, we have assumed the sign changes for the voltage drop across each resistors in this way. Okay, now apply KVL to the first loop. So we will start the loop as A, B, C, F, A. First loop is A, B, C, F, A, and here we can write the equation from A to B. The voltage is positive because here sign changes from minus to plus. And next, across 3 ohm resistor, the voltage drop is negative because sign changes from plus to minus. Voltage drop across 3 ohm resistor is 3 into I1. Therefore, it is minus 3 into I1, and again minus 2 into I2. Or you can also simplify and write 35 is equal to 3I1 plus 2I2 as the loop equation for the first loop. Now for the second loop, let us take the loop F, C, D, E, F, and starting from F to C, here the potential drop sign changes are minus to plus, therefore it is 2 into I2, so which we have written 2 into I2, and from point C to D, the potential drop sign changes are from positive to negative, there is drop in potential, therefore it is taken as minus of 4 into current flowing through 4 ohm resistor is I1 minus I2. So here current enters at this particular point C, and I2 we have assumed it leaving, therefore I1 minus I2 is equal to this resultant current through 4 ohm resistor as per the KCL rule. Therefore, I repeat, for the second loop, the equation is plus 2 into I2 because sign changes as from plus to minus. Next, minus 4 into I2 minus I1 minus I2, and finally here it is plus minus. Therefore, minus 40, or taking this minus 40 to the right side, we can write the second loop equation as 2I2 minus 4 into I1 minus I2 equals to 40. For the first loop, it is plus 35 minus 3I1 minus 2I2 is equal to 0, or 35 is equal to 3I1 plus 2I2 is equal to plus 2I2. Hence, on solving these two equations, we will obtain the value for I1 and I2 as 5 amps and 10 amps. And here they have asked to find the current through 2 ohm. Which current flows through the 2 ohm resistor here? I2. Therefore, current flowing through 2 ohm resistor is 10 amps. Now we can consider another example. So for the given circuit, find the voltage between points X and Y. So we have to find the voltage between point X and Y. So in order to find the voltage between this point, so we have to consider this path. Okay. We have to consider this path. So that is from X to A to B, and B to Y. So in order to find the voltage, let us first see what current flows through this 3 ohm resistor and what current flows through 2 ohm resistor. Again here we can see two loops. So let us take this as first loop and this as second loop. So accordingly I have taken as loop 1 and loop 2. And I said as per our convenience you can take clockwise or anti-clockwise direction. So I have taken the clockwise for the first loop and anti-clockwise for the second loop. So I will assume current flowing through loop 1 as I1 and through loop 2 as I2. Therefore, the sign changes here. Let me just redo it. Here it is minus plus. Therefore, minus plus. For 2 ohms, 2 volts supply, or for the battery, it is minus plus, and hence we take here minus plus minus plus. Similarly, at the other end, so here you can just notice plus at this point. So plus minus we will write, and here negative on the other side. So minus plus we will write here, minus plus minus plus. Okay. So assuming the current directions, we can write for the first loop equation as let us take the loop one as ACXAA, and hence starting from the point A, from A to C, the change in voltages sign changes from positive to negative, therefore it is -2, and across 2 ohm resistor sign changes -2 plus, therefore the voltage drop across 2 ohm is +2 into I1, and here in 3 ohm resistor the voltage polarities are changing from minus to plus, therefore this voltage is considered as positive. I repeat, 2 ohm is 2 volts is -2, and for 2 ohm it is +2 into I1 and +3 into I1, or we can also write 2 is equal to 2I1 plus it is plus 3I1, which is 2 is equal to 5I1, and we will get the value of I1 as 0.4. The value of I1 as 2 by 5, which is equals to 0.4 second. Similarly, we can find the value for I2, so which we have indicated here. Value for I1 is 0.4. I1 is equal to Similarly, for the second loop equation, here it is -1 into I2 -5 into I2 plus 4 minus 2 into I2 equals to 0. I repeat, -2 into I2 -1 into I2 -5 into I2 plus 4 is equal to 0, or second loop equation is 4 is equal to 2 plus 1 plus 5 I2, which is 4 is equal to 8 I2, or I2 is 0.5 amps. Now go back to this equation circuit. So now we came to know the current through 3 ohm resistor and 2 ohm resistor. Current through 3 ohm resistor is I1, and which is 0.4, and current through 2 ohm resistor is I2, which is 0.5. So we can take X and Y point and we can write only this portion. Only this portion can be written as like this way. Like this way. And here Vxy can be written as the voltage drop across 3 ohm resistor, this 4 volts and voltage drop across 3 ohm resistor. Therefore, Vxy is equal to 4 plus 1.2 volts, which is 3 into I1 minus 2 into I2 equals to, we'll get the value of Vxy as 4.2 volts. I repeat, Vxy is nothing but, here you can just see the sign changes, minus plus plus minus, so it is nothing but plus 3 into I1, which is 1.2 plus 4, and minus 2 into I2, which is 1 volts. Therefore, the value for Vxy on substituting I1 and I2, we will get as 4.2 volts. That's it. Thank you.